This is a demonstration on how to claim a reserved name on the Handshake blockchain. The Handshake protocol has a long list of reserved domain names. There's about 80,000 of them. These are names that cannot be opened with auctions on chain. They must be claimed by their legacy owners from the legacy DNS system using a DNSSEC proof. There are 4 years since the Genesis block to claim the name. Otherwise, the names can be open for auction. At this time, there's 3 of those years left. So if you do own a reserved name, you need to claim it within the next 3 years if you want to obtain it. There are verbose instructions on how to do so on hsd-dev.org. What I'm going to demonstrate in this video is a much easier way to claim your name using Bob Wallet, using a user interface added by Jackie Chan, which looks awesome and works great. And there's a lot of different methods to claim the name. So the reserved name list, this is a section of that file. I have .com highlighted here. This file is consensus code. The names on this list cannot be changed without a hard fork. Every full node will look for these names. This is the reserved name list. It includes top-level domains like .com and Alexa top 100,000 names like apparently archdaily.com. They will be able to claim the name ArchDaily on Handshake using this process. What a name claim is a DNSSEC ownership proof. It's this whole blob I'm about to show you smashed into a transaction and sent to the Handshake network. It actually starts here at the bottom. There's this string HNS-regtest and then a big blob of information, and that encodes basically a Handshake wallet address. This one says regtest because it's a testing string. Yours will say HNS-mainnet. So this is a text record that is signed by a DNSSEC key in your zone. That DNSSEC key is signed by a DNSSEC key in your parent zone, the top level domain. In this example, it's .xyz, and then .xyz has its own DNSSEC key that is signed by the ICANN root zone, and that's up here. And this key signing key here, ID 20326, this is ICANN's 2017 key signing key for the root zone. This key is a hard-coded Handshake consensus parameter. So we use this key as a trust anchor to verify DNSSEC proofs. And this entire chain, ICANN signing the top-level domains key, which signs the subdomains key, which signs a Handshake address, that whole chain has to be smashed into a transaction and broadcast to the network, and that's how the name claim works. Another way to visualize that here, I'm going to demonstrate using a test name, HNS claim test1.xyz. That's a real legacy DNS name that I own. And I add a DNSSEC to it, and you can see here's the root zone up here, which signs the DNSSEC key for .xyz, which signs the DNSSEC key for my name, HNS claim test1.xyz. Okay, so I'm going to go through the claim process using Bob Wallet in a couple different ways and show you examples on how this will work. One important thing to note is that, first of all, I am in regtest mode. And Bob Wallet in the top right corner, you can switch from mainnet to regtest. Regtest is a local testing mode. It does not connect to the network. It is not mainnet. It's not real money. It's not real names. It's just a testing mode. The reason I want to emphasize this is because if you are a top-level domain like .com or .org and you want to claim your name on Handshake, you might want to do a dry run in regtest mode just to make sure all the signing works before you actually change anything in the DNS system or broadcast a transaction. The other thing I will say about this demonstration is I am using a hard fork of Handshake just for testing purposes. I've added 2 names to the reserved name list, HNS claim test1.xyz and HNS claim test2.xyz. These names will not work on mainnet. It's just for testing purposes only, and that's how the demonstration is going to work, because I don't actually own any reserved names for Handshake. So in Bob Wallet, there's 2 ways to access the name claim wizard. One is if you go down here to the sidebar and click claim airdrop or name. If you've ever done the developer airdrop, you'll recognize this screen. And down here is a new button for reserved name claims, and you can click this. So we can see if we are ICANN, if we want to claim the name ICANN, we can just type that in, and Bob will tell us that ICANN is reserved, but it belongs to ICANN.org, not just ICANN. Okay, fine. So we'll type in ICANN.org. And it's telling us some information about the reserved name claim. For example, if ICANN claims the name ICANN on Handshake, they will earn themselves 24 million Handshake coins. Plus, they will, of course, control the name ICANN, the top-level domain ICANN on the Handshake blockchain. However, Bob is also telling us that they cannot claim at this time because they do not have DNSSEC set up properly for ICANN.org. We can see this. We can try a couple other names here. Google is ready to claim. They'll get the top level domain Google and a reward of 660,000 handshake, like that. So let's go right to HNS claim test 1. It's telling me that I actually need to do HNS claim test 1.xyz. This is what most of the reserved names will offer as a reward. It's about 500 handshake. And I'm going to click next here. So there are 4 ways to claim a name. It's very flexible because we need lots of different people to be able to create these DNSSEC chain proofs. And if you're a top level domain like .com or .org, you likely are using special hardware for your DNSSEC signing, and we have options to enable that. So there's lots of different ways to claim your name. For most of the Alexa 100K names, if you have a name like HNS claim test 1.xyz, you probably have a DNS manager online, and that's the easiest way to claim, and that's this first button here. So we'll start with this, and Bob is going to tell me that it's going to provide a text record that I should add to the legacy DNS system. So we'll click next. And here it is. This looks like a DNS record, type text, there's the host name, and here's this long string. So this string comes from my wallet. It's basically a handshake address with some extra metadata involved. This means you need to either use a Ledger wallet or be sure you've backed up your seed phrase. This string is connected to your wallet. So think of it like an address that you're going to receive money to. And what you'll do is copy it and then add the string to a text record in your DNS manager. HNS claim test 1.xyz, I actually control using Namecheap. However, I've discovered that Namecheap does not enable strong DNSSEC, which is a rule, a handshake consensus rule. So I've had to delegate from Namecheap to Cloudflare, which does allow me to do strong DNSSEC. And that's what I've got here. So here's my Cloudflare manager for HNS claim test 1.xyz. And you can see I've added a text record to the legacy DNS system, this string that I got from Bob Wallet here. So if I were to dig this name, I would be able to find it. Let's just do that real quick, just to show everybody. Let's dig HNS claim test 1.xyz txt, and we'll see it with DNSSEC because that's important. Okay, and there it is. So here's that wallet address and the signature. So going back to Bob Wallet, we've already done this step, and we're going to click check DNS, and it's done. It's that easy. Bob Wallet resolved that text record in the legacy DNS system, created that chain of DNSSEC signatures, smashed it into a transaction, and has already broadcast it to the network. So we can click finish, and we're basically done. These transactions, these claims are special types of transactions on the network. They won't show up in your wallet as pending yet. That might be something we can add in the future. But if I add some blocks, say I'll add a block to the chain here, and we'll see now it is, the claim has shown up. It's been confirmed in a block. And if we add enough blocks to the chain, we can actually register the domain here. So if you're used to handshake name management in Bob Wallet, everything from here on out is you just own the name. You can do whatever you want with it. You can manage it. You can add DNS records, or you can just send the register, which just finalizes the name claim and releases your funds, your reward back to the wallet. An important thing to note here, however, is that if you are claiming a top level domain, it's very important that when you register, you add the DNS records that are currently in the ICANN root zone. Otherwise, you have a potential to create a conflict with your own name, and Handshake users won't be able to resolve your TLD on Handshake. Okay, so I'm going to demonstrate some of the other ways that you can claim a name on Handshake now. That was definitely the easiest, but if you are an advanced DNS user, or you own a top-level domain, you might have a more secure procedure for managing your DNS, and I'm going to show some of the other options that way. There's another way to find the reserved name claim wizard. If you just happen to be looking at names on Bob, you'll see this, if a name is reserved, this claim this name button will pop up. And here's another way to access it. So I'm going to do my second name now, HNS claim test 2, and we'll click claim this name. You can see it's also HNS claim test 2.xyz. And I'll click next. And first I'll start by redoing that first step. I'll show you if I had put the text record in the DNS, I could also follow the same procedure. Click next and then check DNS. This is going to give me an error because I have not set up this text record in the DNS for HNS claim test 2. I'm going to show you some other ways to claim the name. That's what this error means here. Okay, so that's, now we're going to do these other three versions, these other three procedures. One is to use a local DNSSEC key. So if you happen to have your zone's DNSSEC key on your local computer, Bob can access that, import the private key, sign it, and broadcast the proof. The nice thing about this and the other two options I'm going to show you is you do not need to add a text record to the DNS system. If you have your key somewhere else, like on your local computer or on a hardware signing module, you can sign your text record basically outside of the DNS system and still produce the proof that we need. So we'll look at the local DNSSEC key option. And it's going to give me a list of DNSSEC keys. So these keys are pulled from the DNS system. Bob basically looked up HNS claim test 2.xyz and found the valid zone signing keys in my zone and is showing me here what they are. For this particular zone, I've added 2 because I wanted to test both algorithms, RSA and ECDSA, and we can sign with both because I have both of those private keys here on my computer. We'll click sign with local key. Again, Bob will show me the file names I need here at the top of the screen. And, this is the directory where I'm keeping those keys at this time. Again, this is all just for testing. So, here, let's look for this one, 27259.private. That's right here. If we click that, we're done. Just that easy. And then again, once this is confirmed in a block, we can register the name and all that kind of stuff. I'll go through that a couple times just because it's so fun. Let's see if I try to sign with the wrong key or the wrong file, we'll get an error. So I successfully signed with the RSA key 27259. Now I'll sign with the ECDSA key 32174.private. That's here. Okay, and we've submitted the name claim successfully. So if you have your DNSSEC key on your own computer, there you go. That's one way that you can claim. And this did not add any DNS records to the legacy DNS system. It just used your key to produce the claim and broadcast it. All right, now we got a couple more options here. The next one is a little bit more interesting, offline DNSSEC key. This is actually completely an offline method, as in you can do it with an air-gapped computer. And there's a link here in Bob to use Bind9 DNSSEC-sign zone, which is a program that signs DNS records. If you've gotten this far, you probably already know how to use DNSSEC sign zone. And that's what we're going to do for this procedure. So again, Bob is going to give me a TXT record, a string, and it's going to ask me to paste into the window here both the complete TXT record and the RRSIG for that TXT record. And then it'll complete the rest of the proof and make the transaction. So I'm going to copy this record, and this is the step where you can imagine I'm taking this string and I'm walking over to my vault and I'm getting my offline computer, my air-gapped computer. The next step is going to be, we can imagine, on my air-gapped computer. And so here we are. This is a zone file template where I'm importing some DNSSEC keys. I have my NS record here and an A record, and we're going to complete this TXT record here. So I just paste that string in. And again, imagine this is all on my offline computer. I'm going to sign that zone file. It's HNS claim test 2.xyz. Sign that. Everything looks good here. And then here is the signed zone file. So this file was now produced by the Bind9 application. And what we need is the text record and the RRSIG. We need to make a slight modification to this file because it doesn't copy the name on every line, but that's okay. So where is our text record? Oh, you know what? I didn't save it. Silly of me. Okay, let's do this again. There we go. Great. So here's the text record and the RRSIG. What we need to do is just add our name to these records. So they are complete, name, TTL, record type, data. So I'm going to grab this text record and the RRSIG, copy it. Now I'm leaving the vault, leaving the air-gapped computer. I'm walking back down the hall to my online machine where Bob Wallet is sitting, and I'll paste that data back in. So there's the TXT record and the RRSIG generated on the offline machine with our DNSSEC keys. Insert records into claim, click it, we're done, easy. And then again from here, registration works just like normal. Okay, and then finally is the HSM mode. So if you are top level domain, you very likely are using an HSM to sign your DNSSEC. That's excellent security. That's a great way to manage convenience and security at the same time. If you're using Ledger Wallet with Bob, you get the same basic security model. There's a security hardened device with your private key that does the signing. Everything I'm showing you, you can do with a Ledger Wallet. So you can basically transfer your name ownership from the HSM and the legacy DNS system to the Handshake system using your Ledger device. There's a link here to use BNS-prove. So the BNS library is a JavaScript DNS library that is used in Handshake and lots of other projects. It's written by JJ. This branch is a variation of that library that I've added a PKCS11 compatibility to it. So PKCS11 is a protocol that specifies how to talk to hardware signing modules, for example. And I'll demonstrate that in this step. So we can go down here and see the BNS-prove guide, and you can see some options. So BNS is a library, a DNS library with a ton of functions, and BNS-prove is a executable script in that library that can generate specifically these handshake proofs. You can also use it if you have your DNSSEC keys locally. I've just demonstrated an easy way to do that with Bob. But BNS-prove can also be used with PKCS11 to get a signature from your hardware signing module. And then the rest of the steps will be as follows. So we're going to do this HSM mode. We're going to click next. Again, we've got this text string. This time it does not look like a complete TXT record because BNS-prove is going to handle that for us. So I've copied this string with our address by clicking copy. I've already started this command in a separate window here. Let me describe what we're looking at here. On the left, I am using something called Soft HSM. It is a HSM emulator that uses the PKCS11 interface. So this is how I've been able to test our HSM compatibility without actually buying any hardware. What we're seeing on the left is a list of slots in use on my virtual HSM. At the bottom there, slot 1 is like a weird test slot. That's Soft HSM. You can't delete it. It's always there. At the top, slot 609478430. That's a slot that I created in advance with the DNSSEC key. The DNSSEC key that's actually in the DNS system for HNSClaim2.xyz. So I'm going to use my virtual HSM to complete the claim process. And on the right is the command. So BNS-prove is the name of the executable file in the BNS library. I'm offering it 3 HSM arguments. One is HSM module with a link to a .so, a shared object file. This is the crazy thing about PKCS11. The interface is a compiled library. It's a C program with a header file and functions built in. It's not like an API. It's an actual compiled piece of code. So you need to pass that entire thing. And if you own an HSM, the manufacturer would have given you this library file to pass to clients like this. There's also HSM pin. My pin for my virtual HSM here is 1234. And then HSM slot number is that number on the top left. So that'll be 609478430. If you're an HSM operator, you know which slot you need to use to sign your DNSSEC for your particular top-level domain. The last 2 arguments I'm going to pass are -b, which will export the signature in a base 64 string, which is the format we're going to use, but there's other options there. Finally, the name, HNSClaimTest2.xyz. Finally, I will paste the string that was generated from Bob Wallet. Once again, that came from here. And so what BNS-prove is going to do, BNS-prove does need to be online. It does need access to the internet because it is going to resolve the name HNSClaimTest2.xyz on the legacy DNS system, figure out which DNSSEC keys it needs to sign with, and then ask the HSM if those keys are available. Hopefully they are. The HSM can sign the blob and we'll be done. So we'll hit enter, cross my fingers, and it's done. I will show you briefly if I did not have the -b here, it will actually output the claim in that text format. This is actually DNS zone file format, and it's kind of fun. You can see everything from the root zone through the top level domain down to my own zone HNS claim test 2. So anyway, I am going to run the first command again, the base64 command, pass it to pb copy. So I'll just have it in my clipboard, come back to Bob Wallet and paste this sucker in. This whole thing is that long DNSSEC chain proving ownership of that address, and we'll send raw claim. Oh, excuse me. Here we go. I accidentally copied a little garbage there. Okay, there we go, and we're done. So yeah, I've now gone through all 4 of these modes. These last 3 are a little more interesting and don't involve the actual DNS system. You can sign with an offline machine. You can sign on your with an online machine. If you have your private key on your computer, you can sign with a hardware signing module using this external application called BNS Prove. Any way you do it, then you just wait a couple block confirmations, and you'll see your name, your reserved name claim has been confirmed by the blockchain. And then once your name is confirmed, you can manage it. Oh, Bob's being a little cranky about it, but we can register the name like this. Okay, that's it. I hope to see a lot of reserved name owners claiming their name on Handshake. Again, thanks to Jackie Chan for doing the great job on the UI here. And this feature will be released in the next version of Bob Wallet, along with Ledger. There's nothing stopping you now. We got a great security model here. And I'm looking forward to seeing all of you reserved name owners claiming on Handshake. Thanks.